Here's another example of a Boolean logic expression and truth table problem that one like I'd like you to be able to do on an exam. Alright, so we start out here. Here's a circuit diagram with some logic gates, and our first step is to identify the gates. Okay, so we see an inverter here, or a NOT gate, and then this shape distinctive gate is an OR gate, as is this one. And finally we have an AND gate here. Alright, so we look and we have 4 variables, A, B, C, and D. When I apply the A input to the NOT gate or the inverter, I get A bar on the other side, the complement of A. And the output of the OR gate would then be A bar or B. Alright, similarly I have C and D on the input of the OR gate, so this would be C or D. And finally I can write down the total logic expression because the inputs A bar or B and C or D are applied to the AND gate. So I need to put parentheses to make sure this is clear that A bar or B, that whole thing, is applied to one input, and then I AND that with C or D. Alright, so here we go. That's the answer. That's the logic expression for this particular circuit. Okay. Alright, so the next thing I want to do is construct a truth table. And when I look at this, I have 4 variables. I have A, B, C, and D. And I need to make all the combinations of those variables. Okay, so give me some room here. Let's divide that in half, and then in half again. And one trick for forming the inputs for a truth table. I knew this was going to be long because there's 4 inputs. It's 2 to the 4th possible combinations, or 2 to the 4th is 16. So I had 16 possible combinations. So one trick is to, for the D variable, just alternate zeros and ones all the way down. Okay, for the next variable, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. For the next variable B, we have four zeros and 4 ones. Four zeros, 4 ones. And for the last variable, it's 8 zeros, 8 ones. So there's the pattern for generating the rows of a truth table. Okay, so the next thing I want to do is I want to put a couple of extra columns out here. I want to look at the A bar or B gate, and then I also want to look at C or D. So when I form those, if I do that in pieces, I can then get the total output F by just ANDing those 2 columns together. Okay, so here's our truth table. Alright, so let's consider A bar or B. So what we're looking for where either A bar or B would be a 1. Okay, so A bar is a 1 when A is a 0. So, looking over here, getting some color, let's do light blue. This is, A is a 0, so A bar here is going to be a 1. 1 ORed with anything is 1, so I can put immediately the 4 ones here. Next, I'm going to look for the places where the b variable is a 1. There can be overlap, like here, you know, a bar is already a 0 there, but that doesn't matter, okay? And here are the other places where b is a 1. So I move over and add those, and everywhere else, that logic expression, a bar or b, is 0. Okay, we can do the same thing with c or d. Okay, so we look for where the c variable is a 1. Every place there we're going to have 1s. And we also look for where the d variable is a 1. And so here, 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 here. All right, so let's add those 1s on those columns into that column. That'd be a 0 here. All right, and so now we have the 2 columns. All right, so from there we're looking at the total logic expression for f, and we go back to the answer. It's just the ANDing of these 2 columns. All right, so what I'm looking to spot is the places where both these columns are 1. So here, here they're not both, nothing is included on this third block because neither one of them, or it's not the situation where both of them are 1s. Okay, so right here and here. So on all the yellow highlighted things, the output's going to be a 1. Everywhere else, the output is a 0. Okay, so there's the truth table for that particular problem.